Okay, just a quick video here to try to clear up some problems that we might run into with recursion before we get started. Understanding what recursion is pretty important. It's the topic we're looking at. The actual solutions to the problems will be fairly simple, but we're learning a new method of solving them. So warm-up assignment, basically all this is saying is make sure you can write a couple of methods. These ones happen to be ones that are going to be used. We're going to do recursion for recursive versions of, but I won't say we need to worry about it today. This goes on to kind of explain a little bit about what recursion is. You can read through that. I want you to actually see what we need to see here to sort of maybe have it stick a little bit better. So multiplication, the example. In order to multiply 3 times 5, computers do a recursive addition. That's to say they either add 5 3 times or they add 3 5 times. And I'll be honest, I don't really know and I don't really care. Assuming the statement is this. Okay, so this is the command that I've typed into my code to run the multiplication recursive method. Now basically what this method is going to do is instead of using a for loop to do something repeatedly, or instead of using a do loop, it's just going to call another version of itself to do a simpler question. And as the simpler questions get solved, the harder questions can build off of them. So the basic idea here is if we look at this, we're assuming an answer of 0 as a starting point. If times is 0, so essentially it's saying if I'm doing something like 5 times 0, then what I know is my answer is going to be 0. Okay, so I have a base case here, something that I know for sure no matter what's going on, this will be my answer. If times is 0, the answer is 0. I don't care what the first number is, that doesn't matter. And essentially that would then be returned as my answer. If that's not the case, if I don't have times 0, then basically my answer will be the first number plus the result of multiplying one smaller number. Okay, so instead of 5 times 3 now, I'm going to say it's going to be, the answer will be 5 plus the answer from 5 times 2. And that's what this tries to show down here. So basically 5 times 3 is sent in, and it says, well, instead of doing 5 times 3, I'm going to do 5 times 3 minus 1, which is 2, and I'm just going to add 5 to that answer when you finally come up with the answer for me. This is actually going to call a brand new method, create a brand new method to do the 5 times 2. And then in the 5 times 2, it'll do the same thing. Times is not 0, so it's going to say, well, instead of doing this, I'm going to add 5 to whatever the result is from 5 times 1. So I've got this written down here somewhere. So I've got the actual exact same, I just copied it over basically. And if I run this, I guess first thing is to recognize that I said I had 5 times 3, so I might as well use 5 times 3. And we can see that 5 times 3 is 15, so it's going to give us the right answers. 12 times 6. Oh, I ran out of space, sorry. But it did work. Let's pick a slightly smaller one here. That can work. 10 times 6 is... 4 times 6 is... Okay, sorry, I just didn't leave myself enough space. Not that important. Now, if I come back here, though, let's see if I can get this to work. Okay, I've added 3 printing statements into the program, and essentially it's just going to show me when I run, where I am in the program. You've been doing this a fair bit, or hopefully you've been doing this a fair bit for debugging purposes. Now I'm going to use it for understanding purposes. This is going to tell me what are my values coming in, what are my values that are being sent to the next call of the multiplication recursive function, and what is my result coming out. It'll also let me see when these things happen, which is far more important to me than what is coming out. So let's try this again, and I'm going to go ahead with the 5 times 3. Although admittedly I don't know which direction I wrote this. Okay, it looks like that was the right one. Now if I pull this up, I'll give myself a fair bit of room here, you can see what's going on. The initial call, of course, was what is 5 times 3? And instead of solving that the method decided it was going to call multiplication or multiply 5 times 2. And when multiply 5 times 2 sends back an answer, I'm going to add 5 to that. And so, of course, what happens next is this first method is basically just waiting for 5 times 2 to be completed. So the next thing the computer does is it starts 5 times 2. And 5 times 2 says, well, I don't really want to do that work. I want to wait until 5 times 1 has been done, and then I'm going to add 5 to that answer. So then this method is still sitting in limbo somewhere. This method is also. And finally, this one tries to run, and it says, well, again, I'm not that interested in doing any work for myself. I want to add 5 to whatever the result of 5 times 0 is. 5 times 0 runs, and 5 times 0 knows when times is 0, the method says send back a 0. And so right away it jumps to the end, or it goes through itself. It doesn't have to call another method, and it ends saying my answer is 0. I should have actually changed this a little bit. Maybe I even will. Hang on. Sorry, no need to change it. So what happens is it ends the 5 times 0 call. The next thing it does is it ends the 5 times 1 call by adding the 5. So again, this has been finished. And so this one was the one that was in the process of running. And that one was supposed to add 5 to the result sent back. So then it's ready to finish. The 5 times 2 was waiting for an answer from it. So now it's ready to finish because it adds the 5 to the last answer. And the original call ends with the answer by adding 5 to the multiply by 2. So it's a little strange as a thought process, but basically this can be used anytime we have a situation where there's a base case, a single value that we know if this number comes in or if this value comes in, then I know what I want to do is I want to say, this is my answer. It can be a Boolean situation. It can be anytime this happens, send back a true. And then in other cases, send back a true or false based on that. Typically, certainly numbers make more sense, and most of the ones we'll do will be numbers initially, or at least we'll be using numbers initially. And so basically, I want you to follow that and try to do the questions into the next section. Not sure what else was on that sheet. It's been a while now since I've written it. Okay, so basically just, well, you can ignore the 6.36 thing. Try the factorial first, and then try doing something very, very similar to this for exponents using multiplication. So it should be almost identical, except of course what you're doing is you're multiplying by the result from the one smaller calculation. So 6 to the exponent 3 is really just 6 times 6 to the exponent 2. 6 to the exponent 2 is really just 6 times the result from 6 to the exponent 1, and so on. Okay, so hopefully that'll get you off on the right feet, obviously, or the right foot. Well, maybe both feet. Obviously, ask any questions if you've got them, but I don't want you starting the wrong way and getting thrown off. If you're looking at this right now, you see this answer label.caption. Obviously, that's not the code for you. I was using this on Visual Basic at once upon a time. Anyways, I'm going to stop talking now.